Hello, my name is mahditaghizade, and today we are going to use Cplex software for our optimization problems. As we discussed earlier, we learned about Cplex introduction and its features. Today, I'm going to just solve four additional examples to challenge your knowledge and try to teach it in with some kinds of challenging problems. So, without further ado, we are going to just start with the first problem. The earlier one, wagon allocation, we have discussed it. We do have the code, and if anyone wants the codes, the Cplex codes and the PowerPoint file, please reach me through my email, or I can provide you the files in the link in the description. So, uh, the first problem is about a paper company. The objective of this paper company is to minimize its number of raw lumber pieces, while it is trying to satisfy all of the given demand. So there's three types of demands, and three types of orders for this company. These are three kinds of dimensions that the company should provide. And as you can see here, we have the initial raw lumber dimensions. So there's some kinds of problems which they give you the scenarios, the objective function at first, and you are just going to you have to just try to define decision variable and objective functions. I'm sorry, you have to just define objective function and its constraints. But in some problems, you have to first understand the problem, which is the best way for you to use this software. In order to use this software, I recommend you to just at first try to comprehend the problem. So in these kinds of questions, you have to first try to figure out your decision variable. And this one is one of those ones which you have to figure out the decision variable. So based on these demands and based on these three demand dimensions, you have to figure out all possible scenarios and try to write down your decision variable. So I have written it down. So if you want to, you can just like there is some kinds of the first slide of each example, first or second ones of each example have the question, and the next slides are just the solution. So you can pause the video if you like to and just try to solve it at first and then check your writings, check your understandings with me, and uh, try it on your paper. After that, we are going to just try to write it down in Cplex for each of them. The first one, the scenarios for all of these three demands can be put in five types of scenarios. I'm sorry, I have forgotten to write this down, but this dimension, this one, if I don't know if you can see it or not, but this one is, let me check it real quick. Okay, so this one's dimension is two. It is two, and this one is four. Okay, for all is the same. So when you divide this one into four pieces, they can be all one 1, 1, 1, and into four pieces. So you have five of these one to two dimensions of uh, lumbers. So these are the five possible scenarios which I have tried to write them down. So each of these have like their own kinds of um, demand satisfactions. Well, what that means is, let me just delete all of the page. So this means that all of these scenarios can satisfy one or two or maybe three no, just one or two kinds of demands. And this one in here, I'm sorry, this is wrong. This should be something like this. This is the correct form. I don't know. The dimensions are probably are not that good, but we are going to just try to focus on the understanding of the problem. So, for example, for the first scenario, you have this one, which is 2, 1, 1, 1, 1. That it means you can have four types of four lumbers that are in 2, 1, 11 dimensions. Okay, and this one, for example, the width is 11, right? And this one is something like 1, 1, 4. So it's 2 of 1 to 4 dimensions, the two of these lumbers. Okay, so these are all of the possible scenarios. These are five scenarios. We are going to uh, jump on the decision variable. So we have the decision variable which should specify the number of scenarios providing that are providing the three demands, and the objective function, as we discussed earlier, is to minimize the number of uh, raw lumber pieces. So the objective is to minimize the number of raw lumber pieces, and xi means number of scenarios. Okay, what are the constraints? What these constraints mean, and why did we put this sign of equal or greater than? Why didn't we just like put equal? So there is a reason why we did this, and this is because first of all, uh, I'm sorry, the problem is a minimization problem. So when you want to minimize the usage of these lumbers, the algorithm, the software will just actually put equal, and it will not try to spend more than the required demand. You can try putting in equal, it's okay, there's no difference, but we just put this one, and there's no difference in the outcome between these two because of the uh, feature, because of the minimization problem that we have in here. And these three ones are representing the amount of demand that we have to satisfy for each of these types of lumber dimensions. And so these are demand parameters. And why did we try to use x1, x3 for the first one, x1, x3, and x4 for the first one? What is the reason for this one? As you may not guess right now, this is because of the existence of each of these three dimensions in each scenario. For example, I want to satisfy the demand for the first dimension, for this one, right? I want to satisfy it, which is 1300. Yeah, right? I want to satisfy it, so I have to look up and find all of between all the scenarios which have provided this dimension, right? So this one have provided this dimension, which is what? Which is 1 into 2, right? The 11 is just the length. It's just the like, I'm sorry, thickness. It's the thickness, and these are the dimensions that we want for the rectangle. Okay, so this one have provided the demand we want. This one have provided because of the dimensions, not because we are just like we just like to put it in the constraints. This one's dimensions is 1 into 2. This one is the same. This one is the same. So these three scenarios are possible for providing the demand for the first one, the first type of lumber dimension for the lumber order. The second one, 1 to 4, should be something like this. This, and I don't see anything similar. So as you can see, is x2 and x3. Why is it 2x2? Why? What about the coefficients? The coefficients are the amount of each of these numbers that are being provided in each scenario. So for the second one, for this one, as you can see in here, scenario 2 can provide two of these numbers. So the coefficient is 2, but x3 can just provide one of them, and the coefficient is 1. For the first one, this one is 4, and just guess why? Guess what? Because there's four types of four, not the number of 1 to 4, 1 to 2 numbers are four pieces.